Welcome to Open Source Adventures. Today we're going to talk about Java NIO usage in Kafka. So firstly, let's take a quick look at Java NIO. So either client or server can read or write into the socket channel, so they can read each other's byte buffers. Each socket channel has an unique identifier, selection key, and the selector will be used to manage each socket channel, and each socket channel will register their interested operation for selection. There are 4 operations: Operation read, Operation write, Operation connect, and Operation accept. The API select will return a set of selection keys where the new operations are registered by the socket channel to the selector. The underlying logic of select is related to the system call poll or epoll, depending on the Linux kernel version, where epoll is much faster than poll. Let's take a look how Kafka registers interested operation to read from and write to the socket channel. On the client side, the API selector.connect will invoke socket channel.connect and register an interested operation connect to the selector. On the server side, the acceptor thread will start from registering operation accept and loop over and invoke select. Both client and server will invoke selector.send to attach a send object to Kafka channel and register an operation write. Both client and server will invoke selector.poll, which would invoke NIO selector.select and handles 3 different logic. The first logic is to finish connect. It will unregister the operation connect from the selector and register an operation read to the selector. The second logic is read, which reads the byte buffer from the socket channel. It will simply invoke Kafka channel.read. The third logic is for writing the byte buffer to socket channel. It will invoke Kafka channel.write and unregister the operation write from the selector. Kafka has its own selector class wrapping on top of NIO selector, which adds more functionality to manage socket channels. There are 4 states for channels: not connected, connected, ready, and mute. After the transportation layer finishing TCP handshake and the socket channel finish connect, the status will switch from not connected to connected. If any exception is thrown or the timeout happens, the channel state will remain not connected. After the channel is connected, the transportation layer and authenticator will do SSL handshake or SASL authentication respectively. After the authentication finished, the channel state will switch from connected to ready. If the client or server want to blacklist or throttle a connection, the connection state will switch from ready to muted, and the state can also switch from muted to ready. To better conducting the socket channel operation, for example, the SSL or SASL authentication, Kafka has a Kafka channel class wrapping on top of socket channel class, which has 2 interfaces, authenticator and the transportation layer, aggregated to it, where the authenticator is in charge of the SASL authentication and the transportation layer is in charge of the SSL authentication. NIO selector.select is not thread safe. Each thread will create a single selector, so the set of socket channels registered to a single selector will not overlap. As a result, we can see there's a normal mapping before network client and selectable interface. In Java NIO, the selection key can attach an object. In Kafka, Kafka channel instance is attached to the selection key. Kafka also provides 2 abstractions, receive and send, which allows the user to customize their reads from or sends to the socket channel buffer. Please check this class diagram for details. To send a request, the user will have to construct an abstract request. The network client will convert the abstract request to send instance, which will be attached to the Kafka channel. So in the selected polling, the Kafka channel will be able to let the send instance write to the gathering byte channel. So the transportation layer, which is inheriting from the gathering byte channel, can then write the buffer in send instance into the socket channels. I suggest you reading 3 public APIs in Kafka selector, which are connect, send, and poll. After combining this video with source code, I think you'll have a better understanding about Java NIO and Kafka's usage. If you like this video and want to learn about more open source frameworks, please subscribe to my channel. Thank you. Bye-bye.